Hi everyone, I'm Jeremy. I lead data science at OpenTable, and today I'm going to be talking about recommendation architectures. So first, a little step back about what OpenTable is and what we do. So a lot of people probably know us from doing, allowing people to search for and ultimately reserve at restaurants based on understanding real-time inventory. In the last year or two, OpenTable's been expanding sort of how it thinks about itself as a company and thinking about before, during, and after in the experience. So before, this is someone could be searching weeks before trying to find a restaurant for an anniversary. It could be 15 minutes before just trying to find out what's around them to go and find a restaurant to eat at. During, understanding this is the dish that's great for me to go and try, or allowing me to pay for the meal. Rather than waiting for someone to come by and bring the check. And afterwards, leaving a review or providing any sort of feedback. Just so people have an idea about sort of the data sets, so our network connects diners with about 32,000 restaurants. Our partners spend over $30 billion every year. That's sort of the amount of spend that we're influencing. We seat 16 million diners each month. And every month, OpenTable diners write more than 450,000 reviews. So we have lots of photo content, review content, textual, rating content, et cetera. So there's really a lot of different information that we have about how OpenTable customers are making decisions. The theme of my talk today is really talking broadly that recommendations are a lot more than just collaborative filtering. Often when we talk about these sorts of problems in conferences exactly like this, we talk about sort of niche sub-problems and how we go and solve each one. So the sort of metaphor that I like to use is you've got this big elephant and different people are poking at different sides. You've got someone holding the tusk and thinks it's a snake. You get someone holding the tail and thinks it's a branch. Someone's climbing the back and thinks it's a high mountain. The idea here is to understand holistically what you're trying to do when you're going to provide recommendations. And hopefully I'm going to provide some frameworks to think about broadly how to do that, what the pieces are, and most importantly, how to stitch those pieces together to get quality recommendations. So I'm going to talk about three things today. I'm going to talk about the importance of A/B testing, and that may be sort of self-evident, but how it fits in with other parts of the systems will matter a lot. The second is how we go about generating recommendations, and a third is recommendation explanation. So from the highest level, the goal is actually quite different than what people talk about. We often talk about conversion rate, or we talk about retention. Ultimately, the goal here should be minimizing the amount of engineering time that allows you to move the metric that matters. So building systems that make it easy to measure, easy to iterate, and reduce iteration cycle times are actually the things that matter most, because most of the things that you A/B test, you're going to guess wrong, and you're going to just need to be able to iterate and understand deeply in the data. We've sort of heard as a common theme, people build models and then just sort of let them out in the wild and see how they perform. You really need to do A/B testing to validate your data, and we've talked a lot about that today. If you don't measure it, you can't improve it. And selecting the metrics really do matter because they ultimately drive the behavior throughout your entire organization. If you pick the wrong metrics or you don't normalize by the right things, people will go and sort of deviate off and optimize for a metric in your company that you don't want to. And it's sort of self-evident, but this allows you to continue to make continued forward progress. And I want to highlight, so there's generally two major groups when you're going and doing recommendations. When you're doing sort of consumer-based systems like this. One that optimizes for conversion and revenue. These are companies like OpenTable and Amazon. Or engagement, these are like Netflix, Pandora, and Spotify. So talking a little bit about how to speed up iteration cycles, A/B testing, as I've just sort of articulated, is ultimately the gold standard. It's what matters when it comes to making sure that you're actually impacting your business in a way that matters. Usually that takes on the order of weeks, and that's something you're directly measuring, and it takes weeks because often that's how long it takes to get statistically significant results. So then we can go and optimize models. So now we're building models offline. They're predicting metrics that are hopefully going to be strongly correlated with things that are in A/B testing, and that'll take days. And then we're going to have analytics and introspection, which allows us to understand on the order of hours how quickly you can understand, get insights, and go and ultimately push that into optimizing your models, which then you're going to push into A/B testing. So the thing I want to highlight here is each one of these things along this way is really just a poor man's proxy for sort of the next thing in the cycle. So to talk about this more concretely, in the A/B testing or in the learning side, on the training error, we're often minimizing some sort of loss or convex function. Then we go and worry about generalization error, where we're trying to validate it on some sort of test set. And that's worrying about some other metric, right? Like precision at k, which is not the same thing as the metric you're optimizing for your convex function. Then you're going to go and do your A/B testing metric, and that is yet again a different metric that ultimately matters. So all of these are correlated, you're hoping, but ultimately what matters is picking the thing that will move conversion or engagement. And that actually means that you need to be careful about picking what your generalization error is, and for the same reason that you want to be careful about picking your training or your generalization error relative to the function you're trying to optimize for. Other obvious things about training is that when you're training, you can do it on specific data sets, and oftentimes you're trying to do this to deal with things like sparseness. So if I'm going to go and tune some model that's going to be personalized, well, I'm not going to go and A/B test every specific user and what that feature vector might look like. That's not actually tenable. So you're doing that to compensate for it. Then you're going to worry about how it generalizes to unseen data using hyperparameter tuning. And then online, finally, how does it perform in the wild? And so an important thing that I thought was a pretty grounding example for me was modeling diversity. So if I'm going to go and say I use the sort of top two methods, and I build out some more model, and I work out that for where I am right now, I'm a huge sushi lover. The top 10 restaurants for me around me that I'm going to love are all sushi restaurants. That's actually not a good recommendation, right? Like 3 of them are good enough. I'd rather people put like Italian and New American and other recommendations in there. So that's actually something you want to codify into your generalization error, because that'll ultimately move the metric that matters for your online learning. Other important distinctions are usage can completely change the way people make decisions. So right now versus planning is an obvious one. So if someone's on their computer planning for an anniversary 2 weeks out versus making a decision right now, the results will be very different, right? Like distance, I'm going to factor that in a lot more based on proximity and time than I am for a planning. The cost of being wrong is very different depending on what sort of recommendation you're doing. So music and TV on one side, if I don't like the music, it's fine. I just click next, whatever. If I'm going to go buy a car, I better be really, really sure that I'm going to do that. And you're actually going to have to invest more effort in other things like recommendation explanations, which I'll talk about later, in order to do that. And often search and recommendations are sort of posed as 2 different things. I would actually argue that they're actually one very similar thing, in that search allows you to collect intent about what someone wants to do, and recommendations are a mechanism of leveraging sort of what you know prior about a user and coupling that with the context and intent provided to you by search. So how a recommendation stack like this might work is, this is a conventional information retrieval based stack, but fuses in information that you have from the things like a collaborative filter. So you have query interpretation, you have retrieval, where I'm going to go and get, let's say, the 10,000 restaurants that I want to show you. Then I get information about the item, about the user, any collaborative filters that might be relevant, explanation content. Ultimately, I'll go rank both the item and the explanation together. This matters because my ability to sell you and convince you that this is a good restaurant actually matters to you just as much as the fact that this is a good restaurant, and then ultimately visualizes this out to the user. In terms of context, there's implicit information like location, time of day, whether someone's on mobile and web. All of these things can help inform what sort of signals I might want. So again, if I'm on mobile, I'm probably more likely to want something nearby. Explicitly, someone can actually, if you have a search box, people can say, I just want Italian food right now, or I just want something that's good for an anniversary. and that can allow me to scope things down, but I still want to go and leverage all of the implicit signals and prior information that I have about the user. And another thing that I want to highlight is you need frequency data and sentiment data, and I feel like often that we talk about one or the other as if they're sort of independent worlds. So if I'm going to go and recommend something for an anniversary, low frequency is probably fine, but I'm going to want something that's high sentiment, right? I'm going to want a place that is really likely that someone's going to have a fantastic experience if they go. But if I'm going for mediocre sushi for lunch, I'm totally fine with it being moderate sentiment if it's nearby and it's high frequency, namely I go to lots of sushi restaurants. So ways you can go and leverage this is for frequency data, you can either use popularity or as you get more sophisticated, you can use implicit collaborative filters. For sentiment data, you can just model for good experience, namely high average rating or something like that. You could employ explicit collaborative filter to go and model that. But a good recommendation is really going to drive both and is going to understand how, based on the query and the context that they're asking for, how you might want to recommend things. With regards to ranking, it's important to talk about that there are actually two very different life cycles in building out these sorts of products. It's totally okay and normal, and you don't really have a choice to bootstrap using heuristics when you're going and collecting your initial data. If you're going to build out a version 1 of a product, you just need to get something reasonable in front of users so that people will engage with it and move forward. After that, you can get more sophisticated, and there are many approaches, sort of the general term here is learning to rank, where you can work out what metrics are going to really matter and drive based on revenue or engagement or things of that nature. And so as a way of sort of formulating this, you might want a simplistic version would be expected revenue given the query, the position of the item itself, the user. That could feed all the information. Similarly, you could do that with engagement. And there's regression, rank SVM, landmark. There's a whole literature here. But as I said, at least even the naive models up top don't model things like diversity, so you need to go and factor that in on top. So how you actually go about and training these models is the way we've been thinking about them, and again, you can fuse these into each other, but it's sort of useful to think about them as separate subproblems. First is context-free, so I don't know anything about what the user's trying to accomplish in a specific situation, a specific point in time, and I can train for content-based and collaborative filtering-based models to help me understand, knowing none of that, what is it that is going to be a good recommendation. And I can build an ensemble of a bunch of different of these, and then perform hyperparameter tuning to go and train each of these models and ultimately the model that I'm going to use. Then on top of that, you're going to have search. You're going to have, now I want to understand the context. I want to understand things like distance. It will use as signals things like the context-free model, because that's going to be hopefully very high signal. And then again, I have to perform the same hyperparameter on that meta model on top. And then ultimately, I'm going to evaluate all of these things with different models, using changing models, changing different generalization error, et cetera. So the way this data flows is you might have a collaborative filter that you're doing hyperparameter tuning. So we use Spark a lot to do batch tuning of the data. Then we use collaborative filtering to train our actual model. That model actually gets serialized out and ingested into big servers that then in real time can go and predict for specific users. So the pipeline for batch is very different than the services we build to actually do real-time queries. Then similarly, you're going to do the exact same thing with search. You're going to do the hyperparameter tuning and the search training offline, and then you're going to go in real time provide search results. Then on top of these, you're going to use things like other interaction logs and other services in beyond search. So for example, I'm going to need to know when people reserve. That'll ultimately feed my A/B testing dashboard. So this is the way we think about how we sort of build different pieces of the processes and how they feed into each other to go and provide metrics that ultimately move the needle. I'm now going to take a slight turn into trust. So as I was describing before, even if I give you great recommendations, it doesn't matter if I don't trust that these recommendations are worthwhile. When I built out the first recommendation system that I ever built, I had friends who basically were saying, we can't use your system because I have no idea why this recommendation matters, even if this is the best ranking in the world, and if I sort of follow it blindly, I'll end up at good restaurants. No consumer in the real world is actually going to do that. And as I articulated before, depending on what you're trying to do, how much time and energy you want to invest in explanations and how much of a payoff there will be. So the more I can vet that content up front, the less sort of need for explanations there is. And as I move from all the way on one side, from I can listen to music or I can click on a link and see if I like it, to a restaurant recommendation where I'm spending a night and I'm spending a significant amount of money, all the way through to buying a car. This is why people in different products build out very different experiences and provide a lot more metadata about it. So for example, at Amazon, they sort of started this whole idea with the person who bought X also bought Y. At Netflix, they analyze things like, based on your interest in these 3 things, that's something I'm going to recommend. At Ness, which was a personalized restaurant recommendation site that I helped build, you could imagine that 1,000 people who are similar to you are going to be ones who also like In-N-Out Burger, so that's a recommendation. Or 5 of your friends love this place, so that's going to be a recommendation. So helping understand and ground why this is something that a user at least thinks they understand, how the recommendation is working, can go and provide a lot of value. In addition, it can, so in terms of summarizing content for mobile, this becomes a much bigger deal because you need to balance utility with trust. I have a small form factor of a phone. I'm not going to be spending lots of time reading over reviews. So how do you sort of balance that? The answer is you summarize, but you surface the raw data so that people can review and understand what's actually going on. So the example would be that the first time they come to their site, they may actually go and read all of your reviews, but later on they may just go back and look at the average star rating and rely on that. But if they can't delve in and understand every review in the beginning, they're not going to trust you enough to later rely on the star rating. So ways that we do this, we do summarizing of restaurant attributes, so we can tell you that a place has great service or vegetarian or it's great for a date, and but the point is you can click in and actually understand that it has excellent service. Similarly, for dish recommendations, we recommend what you can try, but you can actually see great photos of the dish. You can then go and see where it's highlighted in the text, so you have a better idea about why this thing's ultimately being recommended. After you've been doing this for a while, you just sort of rely on the top dishes, but you have to go through this pipeline. As a little bit of fun analysis, we did, actually, Sadiq Das in the audience, did some analysis on our data, and you can see that in Manchester, people really like filet steak. In Edinburgh, people love haggis. So it's sort of intuitive, but you could imagine that this allows you to get better ideas about locality-specific things. Going into a little bit of distance or a little bit of information about how we analyze review content, and again, this is work of Sadiq. You can build, initially you just build analytics to understand these are words that are correlated with things that are great restaurant experiences, excellent, recommend, delicious, perfection, and bad ones, slow, terrible, overpriced. These are really useful sentiment words. Pandora sort of started this off with a music genome project, but what's nice is if you have textual data, you can actually learn topics and tags that implicitly give you data to go and build out these sort of models. There's sort of 2 major methods. There's LDA and non-negative matrix factorization. Just a little understanding about how non-negative matrix factorization might work. I might have a review like the food was great, I love the view of the sailboats. Turn that into a vector of 1s and 0s or counts of the number of times it shows up in a different review. There are a number of different ways that you could normalize it. TF-IDF is one. I'm not going to go into that. But you can basically take your review in word matrix and break it up into reviews versus topics and topics versus words. And then this allows me to summarize my restaurant as a function of topics. This can be really powerful for understanding what it is about the restaurant that makes it great. So you can see that things like fish and chips or the East Bay Bridge or difficult parking or great anniversary or wedding, this just sort of pops out of the data. You can also cut it up by region and get intuitive things like people talk about the view of the bay, or they love the Hudson River in New York, or the Tower of London. So these things just pop out of the data. So to summarize the ecosystem of these sorts of tools, the importance of A/B testing and how those A/B testing results are moved ultimately by generating recommendations and how generalization error and training error feed into your A/B testing pipeline. and then how important recommendation explanations can be to really also provide a significant boost to conversion. Thanks.